Morning and welcome to tonight's Four Elements webinar. When this is the final event of our series with Rathbones Investment Management. The four elements are literally that. They've been earth, air, fire and water. And tonight we're going to come to fire. They have been a fantastic series and they're all available online for anyone to look up if they want to. Back in January, we talked about earth, about green capital, about sustainable solutions for our food systems. In February, for water, we looked at oceans and rivers and global water shortages. And we learned about communicating with whales as well as the intricacies of the tidal ecosystems. And in March, our air panel looked at dealing with air pollution in cities, and both knew, which is high tech, and old, such as trees, ways for capturing carbon. It's been fab. Tonight, though, we're going to be talking about probably the most difficult of all of them, fire, because this is an element that has such huge contradictions. We wouldn't be human without fire because otherwise we'd have to eat grass all day. Fire enabled us to cook meat, which enabled us to digest it, and which enabled us to build our bigger brains. But it also has been the source of how we have powered our planet. And as we can all know, this is one of the reasons why we are in the climate crisis that we are in, because we have burnt a lot too much stuff. So we're going to try in the course of the next hour to look at various aspects of how fire has been both our sustainer and in many ways our destroyer, and look at some of the solutions to this. As ever, the webinar is going to last for about an hour. We're going to have presentations from our four fabulous speakers. Then there'll be a few questions from me, and then it's over to you. So please put your questions in the chat box, and I will promise to come to as many as we can. So with no further ado, our first speaker tonight is Juliet Davenport, someone who I freely confess I've known for a long time. And Juliet is an amazing woman. She founded a company called Good Energy when she was only 31, and it was the UK, one of the UK's very, very first 100% renewable energy suppliers, electricity suppliers. She was the first female CEO of such a company at a time when only 2% of the power on the UK's grid came from renewables. She has stepped down from the Good Energy in the last year or so, but she sits on lots of boards and is still massively influential in the sector. And she's also just last year published a book called Green Startup. So Juliet, thank you very much for being with us, and over to you.
Rosie, thank you so much, and thank you for that wonderfully generous introduction. So, I mean, I think you've laid out quite a lot of the challenge that we're looking at here, and the relationship to fire. So, climate change is a problem we are dealing with today. It is not a future problem, and it is driven extensively by our desire to burn fossil fuels, and fossil fuels driving our economies. And that has been going on for sort of over a century now. And one of the reasons I got involved in the industry, I actually started life not as an energy company specialist. I was a climate scientist. And when I was looking at how do you find solutions to these problems, one of the big challenges is that in our status quo world, where people don't believe in change, it's very difficult to precipitate change, to make things happen, because people are so comfortable with where things are already. And the concept behind setting up a company was not only to offer consumers a way to actually make direct action, but also to be in the room where policymakers were making decisions. And that was, for me, incredibly important, because there's so many pitfalls and so many discussions that go on behind closed doors. I mean, I've heard some politicians talk about 1.5 degrees not being very much. And the issue is that they think about that in weather terms. Maybe it's 1 degree warmer than it was yesterday. That's not the climate. If you think about it, how much energy is it taken to take the whole of the atmosphere around the planet and increase it by 1 degree? That is a huge amount of energy that we've put into the system. And it's not just about temperature. Think what that energy is going to be driving. It's going to be driving wind. It's going to be driving precipitation. It's going to be driving storms. It's going to be driving extreme weather events. And so you can kind of see this piece where, in a sense, we haven't talked about the language of what burning fossil fuels has really done to the overall energy in the system of our atmosphere. And if I move to kind of my headline, we have to move very fast. And if we're going to move very fast, for me, there are 5 key areas that we really need to address to be able to do this. And they're quite dull in some ways, I'm afraid, Rosie, and I'll try and make them a bit more interesting than that. But they start off with research and development. Over the last 20 years in the UK alone, we have spent the majority of our research and development budgets on aerospace and automotive and medicine. And climate change and energy have been tiny in comparison. If you look at the billions that have been spent, in the order of sort of 20 billion spent in those areas, only 0.2 has been spent on energy and climate, which means that we haven't been investing in trying to shift the innovation in the research part. That is beginning to shift, but it needs to shift faster if we're going to find new solutions and methods. It's not just about technology, it's about how we do things. The next piece is we built the infrastructure over the last 50 years in a high carbon situation. So our infrastructure for the UK, for example, it's all centralized, it's all in the middle of the country, it's all related to large coal power stations. And that's not just the case in the UK, that's the case worldwide. So we have an infrastructure that was built in a world where fossil fuels were seen as king. And so when we want to transform into renewables or low carbon technologies, they look very different. They're much more dispersed, they're much more localized, they're much more democratic in some ways. And so our infrastructure is fundamentally going to have to shift very, very fast. And this challenge just hasn't been grasped either in the UK or in some of the evolving economies that we're seeing in Asia. The next one is policymakers. And before the chat, we had this really needs leadership, policy making on an international scale to make sure that countries are stepping up and doing everything they can. The issue you have is that unless you have decent leadership at a policy thing, we just keep hearing we keep hearing the same comments and the same money go round and round in circles. We actually need to have, for an example, a national campaign on energy efficiency. We have the worst housing stock in the UK. 85% of our housing is heated by gas. If you're going to be serious about climate change, we need to significantly shift that very fast. And then you've got to look at the skills and leadership that we're going to need to be able to do this. So right now, we are not training enough people who will have the skills that will be able to implement the energy transition we need in this country or internationally. So we are going to have to upskill a workforce with the capability to roll out heat pumps, put in energy efficiency, look at electric vehicles. All those areas, we will need to change our workforce, and our universities haven't got capacity at the moment to train that workforce that we're going to need. So we're going to have to come up with other ideas on how we improve our skill sets. However, if we manage to implement all those things, so we carry on investing, we invest in research and innovation in the existing technologies and new technologies, we deal with the infrastructure, we make sure policymakers are properly leading this sector, and we train up a workforce, we can start to move very fast. But we need to bring all of those things together to really make the commitment happen.
Thank you, Juliet. Thank you so much for sort of setting the scene so well about why we're I was especially interested as to why we're so tied in to the way that the energy systems move and how difficult it is to shake them apart. So let's now welcome our next speaker, who's Melissa Sterry, who is a design consultant who's worked on all sorts of things and indeed has talked at 5x15 before and was absolutely wonderful. She's the founder and director of a biofuturism consultancy and biodesign research and publishing projects. She's going to talk to us about how we deal with wildfires. What are wildfires? Why do they happen in nature? They're happening more often. And what are we going to do about it? Melissa's joining us from France. And so over to you. And I know you've got some wonderful slides because I can see one of them already.
That's right. And I've got some pre-prepared notes because there's a lot to pack in 5 minutes here. But Earth is a paradox in that it's dubbed the blue planet because it's 71% covered in water, but actually it's the only known planet in the universe to host fire, although other planets have the sources to ignite fire, they don't have the critical component to actually sustain it, which is plant life, not to the best of our knowledge. And among other things, the plant life on Earth it's co-evolved with fire. So it's got what you might consider to be a symbiotic relationship. Plants that are in fire-prone regions sync their reproductive cycles and their processes with the frequencies and the intensities and the behaviors of the fires that are local to their region. Fires are not ubiquitous. They are highly complex, and they shapeshift in their given environment, and they're choreographed by not one but several different factors. They sit at the very apex of the Earth systems, and increasingly, of course, they sit at the apex of Earth and human systems, what we might consider to be ecological, socio-ecological systems, and then some. Factors that shape wildfires include regional temperatures, humidity, wind direction, speeds, topography, the biomass state, particularly the moisture levels and the health of the plants in a particular region, ignition source availability, among other factors. And all of these things combine to shape the intensities of fire, which in turn shape the severities. And all of the different pyrophytes, these are plants that have co-evolved to live with fire, have different parameters to which they are evolved to coexist with. Today, however, we also understand that fire has its own agency, and we understand that thanks to, among other technologies, LiDAR. We can actually see inside the smoke plumes. We can see the particles, and we can see that fire has the agency to impact upon its spread, its speed of spread, and through thermodynamics, through convection, radiation, etc. And fire, plants and flora in fire-prone regions have evolved with historical fire conditions. And of course, these historical conditions are changing. So we're seeing changes to the fire-evolved plant assemblies around the world, effectively. Some are evolving for fires that come faster, others more intense, etc. So this is not a state of stasis. This is a state of change. And what I do in my research is I explore the traits that enable these plants, these pyrophytes, to coexist with fire. So the biochemistries, the behaviors, and the relationships of these plants. And I ask the question, what can we learn from that? How can we mimic that in our design systems to create architectures, urban design, material systems, information systems, and the policies and the codes that will facilitate that? And in that sense, I'm not asking how we humans could solve the problem. I'm asking how plants have already done this and how we can actually replicate that. One of the reasons why this is so interesting as a subject is, as Rosie alluded to in her introduction, we are not just a species, we're not just a genus, and we're not just a family that is born of fire. Our entire order, our entire taxonomic order evolved in consequence of fire. More specifically, the primates arrived at the flourishing of angiosperms, of flowering, fruiting plants, which in themselves, it's hypothesized, were a consequence of changes to the Earth's fire regimes. And all along that journey, the fire has shaped every element biologically and behaviorally of our journey. We have found contemporary studies show that our closest extinct relative, the chimpanzees, dance when fire arrives. They celebrate it. Now, we don't know why, but one of the strongest hypotheses is that they are celebrating it because of fire foraging. In other words, we're not the only primate to enjoy a roast dinner. Our closest extant relatives seem to have cottoned on that with fire comes a feast. But of course, in the period since the advent of our splitting from our closest extant relative, fire has shaped the world beyond all imagination, and particularly materially. It enabled us to advance our tool making, in that firecraft made that process easier. And of course, since then, it went on to shape metallurgy, it went on to enable the Bronze Age, Iron Age, aluminium, steel age, plastic age. And so effectively, our entire civilization is built on firecraft. The difference is that we've recently transcended, in geological terms, from working with living combustible materials to lithic materials. And that's where the imbalance, as Juliet alluded to, has come from. And so effectively, we're paying a Promethean price. We stole fire in the minds of the ancients, and that's a universal, a ubiquitous myth. The origin of fire myths all have the same narrative. We stole it, and we're going to pay a price. And so to wrap it up, my work is looking at a whole new architectural school. This is not trying to reinvent a past age, a past material age, but to evolve a biological age where we are working with fire in the same way that we work with nature. We're learning to make fire our friend, not our foe. And like the chimps, we're learning to dance with fire, not play with it. And I think there are many, many exciting possibilities. This doesn't mean going back to the Stone Age, because, of course, we can do this in tandem with advances in material science, information technologies, engineering, design, and lots of other exciting things. And just to flip through my slides quickly, which I completely forgot, I'm just going to go to the end slide and to show you how complex this is. The top triangle you see there, in the fire world, we talk about fire triangles. You see the components that all of the current policies and all of the current building codes rest on. We've got economics, we've got fire science as applies to we humans, anthropogenic, and we have got our firefighting capabilities. The paradigm that I'm proposing is the bottom triangle. And as you can see, there are 9 different factors, 9 different lenses that we have to apply to this. So it's complex, it's messy, but as I said, I think it's very exciting.
Thank you, Melissa. That was full of wonderful surprises and different ideas. And yes, you're right. Fire does run through the whole of our. Certainly the whole of human evolution. Now I'm very pleased to welcome Bill Maguire, who is a volcanologist, a word that's always rather difficult to say, as well as being Professor Emeritus of Geophysical and Climate Hazards at the University College London. So Bill has written numerous books, the latest of which is Hothouse Earth, and he really works on and is going to talk about the impacts of fire on the planet and really what's happening within the whole Earth underneath us and what this means in terms of our futures and geological breakdown. So, Bill, over to you, and welcome, and thank you so much for being with us.
Thank you very much, Rosie, and hello, everyone. Well, I'm going to introduce you to something that's rather unusual, something you may not have heard of, and that is that a changing climate not only drives higher temperatures and extreme weather, it also triggers volcanoes, tsunamis, and earthquakes. This isn't a joke, it's true, we've got lots of evidence for this. Bearing in mind the theme of the talk today, I'm just going to focus on volcanoes because obviously they're the fiery aspect of these different geological hazards. And we can see the relationship between changing climate and volcanic activity particularly well if we go back to the end of the last ice age, because that was a time when at high latitudes you saw ice sheets up to 3 kilometers thick sitting above places like Iceland, Greenland, Scandinavia, etc. And the thickness of that ice and the weight of that ice was tremendously effective in terms of stopping earthquakes happening underneath and also stopping magma getting up towards the surface. So you can imagine if you have a huge ice sheet like the one we have on Greenland at the moment, sitting on top of a volcano, that magma is never going to get through the kilometer or so of ice that's sitting on top of it. But as the ice melts very rapidly, as it did about 15,000 years ago or so, then the crust, which has been forced down, starts to bounce back again. And at the same time, magma, which has been sitting down there waiting to come out for maybe tens of thousands of years, starts to rise very, very rapidly. And so at the end of the last ice age, when the ice melted away, we saw this big volcano storm, if you like, a huge burst of volcanic activity. And this is particularly well seen at high latitudes, especially in Iceland, which is a country that's entirely volcanic. And if we look at Iceland, you can see in the little map in the top left there's a little red blob, which is Iceland at the height of the last ice age. It had about 1 kilometer of ice sitting on top of it. and very little volcanic activity going on. When that ice melted, you had something like 30 to 50 times increase in volcanic activity over a period of about 1,500 years. This was about 12,000 years ago. So it almost literally was a volcano storm. There were so many volcanoes going off here, there, and everywhere. But this isn't something that you only see at high latitudes. Something else that happened at the end of the last ice age was that 52 million cubic kilometers of water, if you can imagine that amount, was transferred from these huge ice sheets into the ocean basins. And as a result of that, the continents went up where the ice used to be, bounced back, as I said earlier, but the ocean basins sank due to the weight of all that added water. And that meant that around the margins of the oceans, you started to see big changes in stress and strain that promoted volcanic activity all around the edges of the ocean basin. So this is an effect that was global at the end of the last ice age, not just something that we saw in Iceland and at high latitudes. Now, that's what happened in the past. Once again, we're starting to melt ice at a dramatic and accelerating rate. So are we going to see these volcano storms happening again? Well, let's take a look at Iceland to start with. Iceland isn't completely covered in a kilometer thick ice sheet anymore, but it does have one of the biggest ice caps on the planet outside the poles, the Vatnajökull ice cap. There are lots of volcanoes sitting underneath that and around the edges. And you might remember the Eyjafjallajökull eruption in 2010, which caused complete chaos in terms of the aviation industry around the UK and Europe. What's happening now in Iceland is that the whole of the eastern part of the island is coming back up again as the Vatnajökull ice cap starts and increases its melting. So a number of colleagues who work on this area with me suggest that we will see what they call a volcanic response in the Iceland area looking ahead. Lots of volcanoes there. We could see the sort of things that we saw with Eyjafjallajökull, only on a much bigger scale. And this is just one part of the world where we may see this volcanic effect as temperatures continue to climb and the ice continues to melt. If we look further afield, wherever there are snow-capped volcanoes, there's Mount Rainier in the US there, Western US. There's another one in Chile, Sollipolli. Wherever you have these, as the ice melts, so it can interact with magma to generate explosive eruptions. In the case of volcanoes like Rainier, it's the ice that's holding the flanks of the volcanoes together. So if you start to melt the glaciers on the flanks of the volcanoes, there's a much bigger increase of landsliding and mud flows, and these sorts of hazards that can extend for many tens of kilometers around the volcanoes. If we start seeing sea level rise accelerating dramatically, then coastal volcanoes might start to respond to the strain that results in coastal areas because of that. So volcanoes like Mount Etna, for example, might start to erupt more frequently. Similarly, Vesuvius and many other volcanoes which are coastally located. And in the tropics, there's a different problem because hurricanes are getting much, much wetter than they used to be. They're dumping a lot of rain on top of landscapes. And where you have volcanoes with ashy slopes and debris that can be remobilized by heavy rains, you have a huge potential problem with mud flows. And the image I show there is of Casita volcano in Central America, where a hurricane a couple of decades ago triggered a major mud flow, which took something like 2,500 lives. So you have a special problem there due to these increasingly wet hurricanes and tropical cyclones. And finally, I just want to really give you an impression of how sensitive volcanoes are to environmental change. There are two volcanoes here. One is Montserrat in the Caribbean, which erupted in the 1990s and 2000s. I was out there as a senior scientist at the observatory. There's a correlation between eruptions at Montserrat and rainfall, because rain gets into the big magma dome at the summit. It pushes down, it turns to steam. That opens up new fractures, which penetrate further and further. And eventually that triggers an eruption. So you have this nice relationship between rainfall and eruptions. And that is seen at a number of other volcanoes too. And then one of my favorites, another volcano in Alaska called Pavlov, this erupts during the winter and autumn months only, because at that time you have low pressure weather systems crossing this part of Alaska that allows sea level to rise only by something like 10 or 15 centimeters, but that added weight of the ocean on one side of the volcano bends the crust under it and squeezes magma out like toothpaste out of a tube. So again, just a few centimeters of sea level change here, triggering eruptive activity. And I think the clincher for all this, in terms of what we're going to see looking ahead, is that there is actually a volcano season. If you look at the timing of all volcanic eruptions for the last 300 years, you will see that there are more eruptions occurring between November and March than there are in the rest of the year. And this seems to be related to the seasonal movement of water around the planet, which causes a planet to change in shape. That change in shape causes waves of strain to move around across the planet, and that favors eruptions at those times of year. So if the seasons can trigger volcanic eruptions, imagine what you can do with, say, another meter of sea level rise, or the huge changes we're going to see to ice volumes and extreme weather. And I think what we need to take away from this is that climate change doesn't only involve the oceans and the atmosphere, the solid earth is involved as well. And the other thing is that, you know, we need to ask the question, are we going to bequeath to our children and their children a more geologically fractious future, as well as a far, far hotter one? Thanks very much.
Oh, thank you so much. I have to say, you told me all sorts of things that I'd never thought about, and I love that last slide with the. I also never realised quite how much all the volcanoes joined up, but of course we heat the earth, we heat the underneath, and that has all sorts of implications that personally, I'd never thought about. So, Bill, thank you very much. And I'll be back to you with some questions, certainly, after the presentation now from Gaia Vince, who is a fantastic writer and journalist and a friend of 5x15s as well. She was the first woman to win the Royal Society's Science Book of the Year when she was awarded the prize in 2015 for her debut, Adventures in the Anthropocene. She's also since then written Transcendence, How Humans Evolved Through Fire, Language and Beauty, and her latest book is called Nomad Century, which personally I thought was one of the most influential books I've ever read about the future impacts of the climate crisis in terms of migration. So this is a subject that Gaia knows really well, and I'm absolutely thrilled that she's joining us. Over to you.
Thanks so much, Rosie. Well, I can't promise to be able to pronounce unpronounceable Icelandic volcanic names like the very talented Bill Maguire, but I will do my best. So we are fire creatures. And what I mean by that is that all life is limited by its need for energy and its capacity to harness energy. So that's a very fundamental thing that we need to appreciate about life, that evolution itself needs energy, and creatures that are more complex have more access to it, and that is both the result of their complexity, but also the reason for it. So plants, whether we're talking about mighty trees or tiny floating algae, get their energy from the sun, and all the animals use metabolic chemistry, or eating, to get that sun energy that's stored in the bodies of those photosynthesizers. But we are creatures of fire. We harness the sun not just through that very slow chemistry of digestion, but in a most dense, rich form by combustion. So when our ancestors began burning stuff, it changed everything. It remade us and our world. So instead of relying on biological evolution for our powerful anatomy and physiology, we used fire. We cooked our food. Just remembered I've got slides, I should show them. There's our ancestors. So we cooked our food using fire to do most of the work of our jaws and our teeth and our guts, because fire sort of externally digests tough raw foods. Fire kept us warm without fur. It was able to scare off our predators. We didn't need claws and muscles or roars. and it cleared landscapes for us to hunt. So fire essentially allowed us to evolve into these puny little mammals, which socialized around campfires, telling stories, hunting cooperatively, and changing our world. So as we evolved, we were able to evolve smaller heads with these smaller jaws, which helped us allow language to develop. Now, fire also allowed us to roam the world. It allowed us to disperse. Socializing around fires extended our day, enabling us to bond with each other. And this is something that was essential in forming the networks, the social networks which humans have, which allowed us to roam beyond our small sort of ecological niche. We were able to rely on neighbouring groups in order to find where was the best place to hunt and where resources were, and to trade things. These networks were absolutely essential in allowing us to disperse globally, and fire helped with that, of course. If you look at our closest living ancestors, the chimpanzees, they're still very much living in the same tropical forest niche that they have been for millions of years, whereas we live from the tropics to Antarctica to the Arctic. But as we burned more and more forests and fossil forests of the world, we became ever more powerful and ever more transformative of the world. So fire gave us bread from grasses. It gave us bricks from mud, swords and plows from the planet's rocks. And the cost of this energy is priced into our foods, our homes, into every single thing we buy. Everything relies on energy. And we can forget that, you know, in this sort of ubiquitous world where everything is easily available and quite cheap. We forget that there is an energy cost to that. And it's something we're going to have to factor in a lot more as we change that enemy supply. Fire has essentially allowed us to eliminate famines in much of the world. It's made some people very rich. So through the green revolutions, through the ability to transform different materials into accessible nitrates to allow us to grow foods. In other words, we can make fertilizers through the chemical reactions, all of it based on fire. So fire has made us the most powerful species on Earth. But of course, belatedly, as we realize how all this burning is changing our climate, we're in the midst now of a most profound revolution. So we, the fire creatures, whose evolution, whose planetary dominance and success has been built on hundreds of thousands of years of burning stuff, are going to stop doing it. We're going to give up burning it, because it turns out that our superpower is killing us. So we have to give it up. It's a bit like an eagle ripping off its wings or a fish giving up breathing underwater. Only, of course, it's not quite like that, because we are so adaptive. We're going to switch from burning the biologically stored sun's energy to capturing it directly from the sun, like plants do, only much more efficiently and much faster. And as we harness the sun, wind, water, and the earth, of course, we're entering a new era for our species and its relationship to the planet. If you think about how fire has allowed us to so utterly transform our planet, I think it's really interesting what is coming as we transform that energy system. What lies ahead? Could it be much cheaper, much more abundant energy that is much more democratically dispersed through local cooperatives, through locally owned cooperative solar farms or wind farms? Are we going to completely rethink our relationship to trees, to the fossils that we find underneath the ground? But even while we metamorphosize from fire creatures to electric beings, fire is moving us, literally. And that's because the dangerous global heating caused by all our burning is creating this new Pyrocene era, where fires are more frequent and more devastating everywhere. Excuse me. From Australia to Canada, from Asia to Europe and up into Siberia, fires are destroying wildlife, property, and people's lives. This is Australia. And I've witnessed several wildfires in Australia, and they are extremely frightening because they move so rapidly, and because the heat front is, I mean, it's obviously invisible, the heat, but it's so utterly devastating, and the sucking of the oxygen. But they are becoming much more frequent, and they are destroying enormous amounts of wildlife and property and people's lives. People are having to be moved, to be evacuated. This bushfire was in Britain. We are seeing wildfires, even in Europe. Hundreds of people died in European wildfires just last year, and thousands had to be evacuated. And the fire season started much earlier this year, with evacuations and thousands of hectares of land destroyed in Spain in March. And the situation, of course, is far worse at more tropical latitudes, and it will only worsen over the coming decades. So even as we move to new forms of energy, we are risking intense fires across the tropical region, particularly in a belt where this heat is very intense, but also all the way up to these burning peatlands underneath the ice in Siberia. We're seeing burning of forests all the way up the American coast, for example, and people are still building houses there, even though these houses are now uninsurable. And what it means is that people are going to have to move. They're going to have to migrate away from these very dangerous zones. We're going to see huge amounts of mass migration because of this climate change that we've caused. And we have to start talking about how we're going to manage it. People are going to have to leave these unlivable places. They're going to have to move to safer places. And we're going to have to think very carefully about how we design and build and locate houses in safer areas, and make sure that they aren't, by design, very dangerous, which unfortunately is the case in a lot of places that we're building now. So will we escape our fire culture before the fires destroy us? I'll stop there. But I go into more detail in my book, Nomad Century. Thanks.
Gaia, thank you very much. Well, I've read Nomad Century, and I know how scary the picture that you paint is, because it is, it is a really scary future. So, Juliet, let me come back to you. I mean, what one realizes that how much fire runs through everything. How realistic is it that we're going to be able to switch to a different form of energy? And please, by the way, everybody, we've got questions coming in. Please put your questions now in the chat box for our panel, and we'll do our best to come to them.
So Rosie, yes, I mean, we have the resources, and renewables are now cheaper than any other form of energy. So some of the things that we put, the blockages we put in the way of developing a renewable future, a lot of those have fallen away. So the cost has fallen away. Renewables are now cheaper than fossil fuels. The big issue, and the massive issue, the unseen issue, is the infrastructure. So if you've ever, I don't know whether you remember Dad's Army and the map of Dad's Army with the sort of the advancing different parts of nations, that's what our gas pipeline looks like. So our gas pipeline, we are completely interlinked to Europe. The UK imports about 50%. The rest of Europe imports most of it from Russia, which has caused this big Ukrainian issue recently. And so we've got to shift away. But at the moment, what's happening is governments are so desperate to bring energy prices down, and they're worried about security of supply, which is completely understandable in the short term, is they're making long-term investments. We are building more gas pipelines now than ever before because people are worried about what's going on in Russia. And what that does, that infrastructure, as soon as you put it in the ground, it has a 40, 50-year life cycle. So somebody will have it on a balance sheet, which will mean that they don't want to write it off, which will mean they want to keep using that infrastructure as long as possible. And that's one of our biggest challenges, is whether it's how much oil is in the ground that's on big oil companies' balance sheets, or coal, how many gas pipelines are on the ground that are on a balance sheet. No CEO of those companies will want to write that off. So somehow government is going to have to intervene and either insist that they start to write down some of these assets that support pension funds, that support the whole of our economic system. Otherwise, we're going to be stuck, and the slowness will slow us down. So the opportunity is there to do it. We have the capability, and we have technologies and the economics to do it at price, but the incumbents are preventing it just by their economic structures as it is.
Thank you. Now, you had a question, you put in the chat that you wanted to ask Bill a question. So why don't you do that and ask?
Okay, Rosie. So Bill, what I was fascinated by, because all these systems interlink and you get a feedback mechanism. And obviously, one of the things we all remember when volcanoes erupt, you do get a form of cooling, do you not? So there's a certain amount of with that many particulates in the sky, it stops all the aircraft flying. So, I mean, do we get to a future where actually nobody can fly anywhere? So actually we reduce 7% of global emissions anyhow, just because we've reduced air flight. And would we start to reflect back heat and actually see a cooling? I'm just asking. It's a fascinating problem. I'm sure you'll tell me otherwise.
No, you're absolutely right. Yes, big volcanic eruptions pump out a lot of material. It's not actually the ash; it's the sulfur dioxide they pump out, which mixes with water vapor in the stratosphere, and it forms a mist of sulfuric acid droplets. And that's what's really effective at reflecting solar radiation back into space. So it does have a cooling effect, which can be very, very significant on the lower atmosphere. There was a big eruption in Indonesia in 1815, the Tambora eruption, which led to appalling summers the year after. 1816 is known as the year without a summer. So the effects can be huge. Now, it would be nice in a way if through heating up the planet, we triggered lots of volcanic eruptions, which cooled us back down again. But I'm not convinced that the volcanic response is going to be quite that big. And there would, as you say, be lots of other negatives as well. So the fact is, we will probably see an increase in volcanic activity, but global heating is just going to keep on ramping up if we don't act now.
It does point to another potential solution to the heating, though, of course, which is deliberately injecting sulfates into the stratosphere to cool us down.
But
yeah, I'd hate. I mean, geoengineering like that is, in my opinion, a massive distraction from doing what we need to do, which is slashing emissions. And in fact, if world governments think that there is a geoengineering solution, then you can say goodbye to any serious attempt to cut emissions, because they'll think, we've got a backstop here, we don't need to bother, let's keep on business as usual. Yeah. So, it is a big issue, but, at the same time, because volcanic eruptions can cause have these huge impacts across the planet, affect weather as well as climate, deliberately simulating a volcanic eruption is a huge experiment. And, it should be very, very much the last resort.
Yes, I would agree with you about that. And I also get quite frightened when people say we can find the technology to get us out of the problem. I mean, Gaia, when you ask that question, do you think it's a reality that we could do things like shooting mercury or whatever into the atmosphere to?
Well, not mercury, but sulfates. Yes, I think it's very likely to go ahead in the coming decades, because climate change is getting more and more dangerous, and people are already dying in large numbers. And I think it probably will be used. I hope that we have conversations about it and democratically decide how we do it, if we do it, and decide whether to rule it out or not, and use it under what circumstances, and actually have proper debate about it, so that it's not deployed under some sort of emergency unilaterally by a state after some terrible disaster.
Yes, well, I wanted to build. I wanted to come back to you with the question, though, which always is: why don't we use more geothermal heating, given that the core of the Earth is incredibly hot? And I know there are small projects around this, but at the moment there aren't any big ones on the grounds that you have to drill down too far. But quite frankly, we've just sent a rocket off to Jupiter or wherever that's going to take 8 years to get there. So why don't we use the heat of the Earth in more constructive ways?
Well, you're absolutely right. There's a massive amount of heat down there. We don't need to go down huge depths either. I mean, heat pumps are now becoming very, very common, and they involve pipes just a few feet beneath the surface. So, we don't need to go down several kilometers. We can pick up a lot of heat by recirculating waters just down to maybe a few hundred meters or 1 or 2 kilometers. And it's a technology that's been around for ages and hasn't been utilized because fossil fuels have just dominated the whole energy landscape. And you could say the same thing, particularly in the UK, about tidal power and wave power, which we've been pushing for 50 years maybe. Tidal schemes are tremendous if the environmental issues can be addressed, and it's something that we're just not doing. The government's turning them down. Severn Barrier, Swansea Bay project, all these sorts of things. So there are many, many alternatives to fossil fuels, not just solar and wind.
And I think it goes in a lot to what Juliet was saying earlier about sort of sunk costs. We built these kind of gas networks, whereas Germany did this kind of community heating. So they were able to sort of move to more efficient heating of communities faster than us, and also they've kind of decided to invest in it, unlike us. But because we have these gas pipes, we're going down these crazy kind of, shall we have hydrogen instead to heat our homes, which everybody knows is a nonsense.
And Guy, that has nothing to do with whether we should use that technology or not. It has completely to do with the fact that people who own the pipes don't want to switch those pipes off, and they want to have a future for them. And so they're desperately trying to figure out, rather than the right solution for what we should be using, which heat pumps and energy efficiency are a really good, effective way forwards. We're trying to, and the point about the hydrogen molecule is it's tiny. So it can get through. I mean, the existing pipelines won't work with hydrogen. Basically, it will escape. And that's absolutely no use to anybody.
It's quite scary. It's very flammable as well.
Yes.
Melissa, coming back to you, I mean, given that lots and lots of people, I mean, as Gaia pointed out, lots of people are living in areas where there are wildfires. It's still astonishing that so many people live in really, really dangerous areas now of California. But what can we do in terms of like rebuilding a future that will work with will be adapted to the climate situation?
I think the first thing we need to do is to be aware of our bias and the fact that actually it's not just nature, but actually human communities around the world have already solved the problem. If we look to Bronze Age architectures, if we look to the indigenous peoples, and I'll take California, which is my specialist region, moving to the wildland urban interface, to the place where fires are native, they're indigenous, they are utterly imperative to the local ecologies. There are literally many species that will go extinct if the wildfires are not there. The peoples of those regions, which in California, one example would be the Pomo people, having lived there for 11,000 plus years, have already evolved architectural systems that are designed to coexist with the fires. They've also developed land management systems. And the reason that those became shifted was not an issue of design, but of politics. It was the matter of European colonization, taking with it a fear of fire, the sort of demonization of fire, because, of course, Northern Europe is not a place within which fire culture was prevalent. And there was this idea that you should control fire. So this whole narrative. In order to do that, we have to ask some very serious questions. I mean, if you take California or many other places as an example, it's not as simple as simply being able to move out of those regions. Because, of course, if you look at cities like Los Angeles, it's built on a wetland. Most of the Californian cities on the coast are built on wetlands. It would be like saying, right, well, London is very likely to have a storm surge, so we'll move everybody out before that happens. So the question is, how many regions can they migrate to? Now, a fire ecologist might classically say to you, let's get everybody out of the fire-prone places. But in reality, you've got the fact that there aren't actually that many places when you factor in all the different natural hazards where they can go to. Are we humble enough that we can actually really re-examine our values? One of the things that's interesting about looking to ancient cultures is there is this notion of sacrifice. And somebody asked the question, why did I say fire was stolen? Well, every single origin of fire myth from around the world, from Northern America, classical Europe, everywhere you look, and it's a ubiquitous myth. It speaks to us stealing fire, and the reason within and of those myth structures is because with the control of fire comes responsibility. And I think that we have to re-examine that, and we have to look at this as a design problem, because as with the energy, Juliet mentioned the fact that Britain has let's be honest about it, a diabolical level of housing insulation. We've got an entire architectural sort of structure that is built around easy access to lithic carbon, to burning fossil fuel. That's why we've got this problem. We can design homes that don't need any heating at all, whatever the weather. We can do that, and we can also design other things. Every facet of the house and what we use can be designed for a low energy system. But we're not doing that, and we're not doing that because of vested interest. So I think the answers are out there. But for me, the big question is not is ours the intellectual agency to create this stuff. It is a question of whether or not we can push through the political bias and the vested interests.
Yes, well, I couldn't agree more about having to push through the political bias. Now, we've got lots of questions coming in from our audience. And Juliet, I mean, something that's just been around a lot in my life at the moment is to do with community heating, community energy. And the question is specifically about London boroughs. But I guess we could extend the question outward into any kind of community. How would community heating, community energy work? And how feasible is it? What needs to happen to make it happen?
So I think the big challenge is that you're competing directly with gas pipelines with it already incumbent. But there are completely the technologies that you could do in central London. I've seen some really interesting where you drill down, as Bill was talking about, you drill down about sort of 200-300 meters in a spiral impact, so you don't have to take up a lot of space on the surface, because that's your big challenge in London. And you can actually spiral it down outwards and then create a low temperature heating ring, which you then put a small heat pump in each house, which then concentrates that heat into the house. And that's how you can do it. You can leverage it around. And that's not a massively complicated system, because with low temperature heat, you get less temperature loss, you get less heat loss. So you can design these things to actually be relatively straightforward retrofits comparison to systems we've got before. But I mean, I'm seeing some really good ones, and particularly in university campuses, where they've got enough space and opportunity to develop that. And you could start to think about how universities could be the center of a community where the university actually puts the heat pump in, but it provides heat to a wider system rather than just the universities.
That's really interesting. That Gaia, coming on to you, and something picking up from Nomad Century, the notion that, and this comes also into, I think, what a lot of other people are talking about. So if we get imaginative about what's going to happen, well, your view that we won't in not many years' time be able to live in the middle of the earth, people will want to move north. We have to think how we're going to redesign how we live. How do you see that happening? Because you're talking about people living in Alaska, people living in northern areas of Russia on what was tundra. We're going to have to be very clever about it, and also very global. rather than just an individual setting off with a suitcase kind of thing and a lot of money, possibly.
Yeah, I mean, we absolutely do, and we're going to have to start managing this much better than we are at the moment. We have this this really ridiculous way of dealing with migration. We demonize migrants, we demonize people coming for safety, and they're very small numbers of people. We need to start thinking of us of citizenship as a sort of responsibility to other people, to other humans around the world. We are actually signed up to international charters to protect people, but what we're talking about is a step change in the current very small trickles of migration that we're seeing at the moment. We will be seeing a lot more just because the climate impacts that are built in. I mean, we're going to cross 1.5 degrees above pre-industrial average in the next few years, and the temperature is only going to rise. So we do need to start thinking about how we deal with people moving. We need to connect people to people seeking work, to labour opportunities. And when we factor in, for example, that a lot of northern latitudes are experiencing this massive demographic crisis at the moment, where we're not having enough babies to support the ageing population, we are going to be competing for migrants as well. We already have terrible shortages of labour in everything from hospitality to medicine to doctors to nurses to farm labourers, truck drivers, really across the board. And that's been driven a lot by our immigration policy, by things like Brexit. So we can be smarter. I do think it needs some sort of global coordination, but it will also need regional agreements, bilateral agreements between nations. In some places, we already have a model for how that might work, like the European Union bloc allows freedom of movement around that bloc. We're going to have to find ways of expanding that and coming to other agreements. Other blocs, like the African Union, is also coming up with something similar, and there are agreements between other regions as well.
And may I just add that, I mean, we're going to have to think about how we reskill these people as well, because
absolutely,
they're going to have to adjust to a completely different economic and community situation, and we're going to need them for the energy transition we're trying to deliver on.
Yeah. I mean, everything, wherever you live on Earth, you're going to, everything, this is a huge upheaval the next coming decades. We're going to have to change everything, our energy system, our food system, our buildings, our materials we use, the architecture and the planning of our cities, how we travel, like literally everything will have to change. And of course, that provides also many opportunities for new innovations and industries as well, which will need labour.
You used the expression just then, in the next decade. That means that the laws we make now become unbelievably important, doesn't it?
Yeah, I mean, we're already experiencing climate change. We're already this transition. We can't really see it because we're right in the middle of it, but this transition is very much underway already. We've probably passed tipping points. We've passed tipping points for renewable energy generation in terms of the economics of it. It's already cheaper, to build new solar or wind power stations than to keep supplying an existing coal-powered station in many parts of the world. We're passing tipping points for electric vehicles. This is a transition that's underway already. And yes, we absolutely need to start thinking much more long-term, and not this, not knee-jerk reaction is not appropriate anymore, given the crises that we face. We do need much, much better leadership.
Bill, just want to come to you with a question that actually came in ages ago, at the moment you put up your last slide with the extraordinary diagram of where all the volcanoes were. The question is, it's interesting that countries in both the North and South hemispheres have erupting volcanoes during the November-March period. Is there no difference between the hemispheres? And I'd like to add to that, in terms of what we're talking about, and Gaia's talking about, and everyone's talking about, that we're going to have to move, we're going to have to incorporate the kind of what we've done to the planet. Should we go near volcanoes or not?
Well, first of all, there isn't a difference between the northern and southern hemisphere. It looks as if over the course of a year, every year you get a movement of water back and forth as you get the northern hemisphere winter and then the southern hemisphere winter and back to northern. The same movement of water triggers changes in the shape of the earth. So it's almost as if the earth's a bit like a beating heart from one year to the next. And that changing shape changes the strain pattern in the earth, and that in turn triggers volcanoes to erupt that are just about getting ready to erupt anyway. So it affects the whole planet in a similar way year after year. In terms of living near volcanoes, well, there are about 500 million people living in the danger zones around volcanoes. Already, it's difficult to cope with volcanic eruptions when they happen, to get people to respond. So, ideally, we would want to see not necessarily less people living around volcanoes, because obviously the soils are fantastic for growing things. The climate's great because they're often cooler as they're higher up. We wouldn't necessarily want to see less people living there, but we would want to put some more money into volcanic prediction and getting people out when eruptions start to happen.
How good are we at predicting them now?
Well, we're quite good at predicting eruptions. I mean, we can't predict earthquakes; they're essentially unpredictable. But volcanoes never erupt without warning signs. They swell as new magma comes into them. They trigger little earthquakes as the rock is fractured as magma rises. So we've quite often got at least days and possibly weeks or even months' notice. So it's something that we can already do, but we're just not looking at enough of them. There are 1,500 potentially active volcanoes. We're only monitoring a few hundred, really.
Thank you so much, and thank you to all of you. I'm going to just come down the line, so to speak, and just ask you all one last question about, I mean, obviously our humans' relationship to fire is so fundamental that I suspect that most of us barely think about it. When you put your gas in your tank or you turn on your central heating or whatever it is you're doing, you're not aware that at the end of it, something's burning. You're extracting something that's burning. So what would be the best ways that we're obviously not going to get rid of it because we're going to go on cooking food, we're going to go on doing things, but how should we change our relationship to fire? Juliet.
Well, obviously, I mean, I think sort of changing it from fire to electricity is for me the transition that we need to think about. And I think Gaia talked about the fact that electricity is going to primarily be driven by the sun, or in fact by the geothermal system. So we're going to get our energy from those two systems, and the transition that we're going to take that through is going to change. And for me, actually, I mean, I always think about it. I always remember watching Harry Potter with my daughter years ago when it first came out and thinking about magic. And actually, for me, power and electricity is a form of magic that will underpin our society. So we should be really celebrating the fact that we can move to these cleaner technologies and actually clean up our lives from an air pollution and a wider piece. This future could look incredibly positive. What we have to do is figure out how we leave the burning future behind, the burning past behind.
Great idea that we switch from burning to magic. I think that's lovely. Gaia, I'm asking you next because you're next on my screen, and I will come round to you. How should we change our relationship to fire?
Well, I love that. I mean, I love that. Electricity is magic, isn't it? I mean, you can't see it, and it does all sorts of incredible things. I mean, we really are making that transition. We will not be able to buy gas stoves soon. They will all be electric, and actually they're just as efficient, if not more efficient, because you're not heating the air. You're literally just heating what needs to be heated. And the same with heating our water, heating everything will be done through electricity. So it will be that kind of magic. But there is also this very this important relationship that we have that's very primal with fire, that amazement when you light that spark, and you see it in everything from the smallest child to the oldest person. There is this wonder associated with it, and instead it will become, I think, that precious, exciting, ceremonial part of humanity, rather than that cause of indoor air pollution, of outdoor air pollution, of charred, disgusting charred landscapes and devastation, which is what fire has become. So I look to a cleaner, fairer future.
Melissa, what's your answer to the question?
Well, I think the big issue we're dealing with here is change. And for many people, the idea of wildfire, the idea of eruptions, and the idea of migration is that which elicits fear. And there are two ways that humans respond to fear. We either run towards it or we run away from it. We know that from psychological studies. And the people that run towards it, the people that are building bridges, are not our problem here. There are lots and lots of people that are working on concepts that can help us to coexist with the great challenges ahead and to mitigate those challenges. It's the people that are fearful and that build the walls that respond to this by trying to block out change. And so what I think we need to do is we need to dial down the fear. We need to actually elicit and inspire their ideas as to what our future could be. We can use design, we can use engineering and science to create some very exciting futures where we are, we're not impoverished. Yes, we will have, big things to deal with, but there can be a lot that we can harness to make our life better, not worse. And if we can do that, I think that would be the biggest step, certainly towards changing policy and codes.
Thanks so much for that. And Bill, final word to you.
Well, last month, the IPCC issued a final warning on climate change. The response of the UK government was an increased dash for oil and gas. In the United States, climate-friendly Biden announced the Willow project, a huge oil project in Alaska. He announced, gave the go-ahead to exporting more liquefied gas from Alaska. He gave the go-ahead to a huge drilling program in the Caribbean. Well, this just isn't good enough. We have to stop burning fossil fuels in the next 10 years. So we need subsidies to fossil fuels, which are provided by national governments, to go. They amount to over $1 trillion a year. We need insurance companies to stop insuring fossil fuel facilities. We need banks to stop lending them money. And we need a carbon tax at the wellhead and the mine entrance, which makes it not affordable to get this stuff out of the ground, because we just don't have any time left.
Well, thank you very much to all of you, to Bill Maguire and Gaia Vince, Juliet Davenport, Melissa Sterry. Thank you for that tour de force around fire. There is so much to think about what you've said. Thank you all, everyone, for being on board with us and for being here for all 4 of these webinars. We've had really good fun and I've learned such a lot from doing them. So thank you all. And I'm sorry that it's always webinars you end up saying just good night and then that's the end. But stick around and there'll be more coming from 5x15 and probably with Rathbones too. So thank you and good night.